I'm Patty Simpson with Simpson Math. Let's make a few histograms. Here I have two different data sets. The first one is the prices of 3D TVs, and the second one is the professor's commute, or the miles that a professor drives to work. We created these frequency tables earlier. So we took our data and we created them into frequency distributions. So we know that in this case, I have 1, 2, 3, 4, 5 classes or bins. And in the first bin, there are 2 TVs within that price range. There are 5 within this price range, etc., etc. And we saw that the width of each fire bin was 100 because we went from 1500 to 1600 to 1700. Remember that in order to find that width, we first found the range of our highest data value minus our lowest data value, and we divided by the number of classes or bins we were going to have. Again, you can look at that in the same place where we did our frequency tables. So we're going to take this data and now create a histogram. Remember that a histogram is used for quantitative data, like dollars. So with the histogram, what we do first is we draw a vertical axis, and this is going to represent our frequencies. And then I'm going to draw a horizontal axis, and the horizontal axis shows my categories. We already have our categories divided up for us. The first bin is going to be from 1500 to 1599. So along this horizontal axis, it's just a number line, and I'm going to treat it as such. I'm going to start at that lowest class value, that lowest limit there, so that I'm at 1500 is my starting spot. Then I need to make sure that I count by a consistent amount. Whatever I've decided to count by, that's what I need to count by my whole time. So if I count by 1500s or by 100, I need to make sure that I count by that the whole way. And since my class width was 100, it makes sense to count by hundreds. So from 1500 to 1600, same width, 1700, same width, 1800, same width, 1900, and last but not least, 2000. Now, I'm going to put my frequency. Remember, we always start our frequencies at 0. I only need to make it to 5, so I can count just by ones. 1, 2, 3, 4, 5. If I had a larger data set, I might have to count by a larger number, but I would still need to start at 0. I need labels so that my reader knows exactly what it is that we are presenting. In this case, these are prices. Maybe you even say in dollars. And then on this side, this is the frequency, or you could say the number of TVs. So those are our frequencies. Now I'm just going to draw bars to represent each one of those frequencies. So this first bar needs to be too tall. Remember what this bar represents. That bar that is too high shows that there are 2 data values that are between 1500 and 1600. I don't remember what they are. Maybe they're 1594. Maybe they're 1599. Maybe they're 1500. I just know that they fit somewhere between those 2 numbers. And there are 2 data values that are within there. Then there are 5 within 1600 to 1699. So I make that bar go up to 5. There are 4 in the next class or bin. There are 5 in the next one. And in the last bin, they're back down to 4 again. Notice how my bars touch each time because we're on that number line. Now there are a few confusing things here about the histogram. For instance, this 1600. What if I have a TV that is 1600? The price of it was 1600. Where exactly does it fall? Does it fall in this bin here? Or does it fall in that bin there? What about 1700? Which one does it fall in? Typically, we just kind of have a rule that the data value would fall to the right. So in other words, if I had a TV that was 1600, it would fall in the bin to the right. But if I wanted to make this a little more precise for my reader, I wanted to make sure that my reader knew where that 1600 fell, I could make these values in here, make it obvious where it falls. I could use the midpoint between here and there to show where each one of them falls. Here's what I mean. The midpoint is right in the middle between 1599 and 1600, between my upper bound and my lower bound, between that maximum of this class and the minimum of that class. So what's right between 1599 and 1600? Well, it's 1599 and a half. Or I could write that like this, 1599.5. Now, if that's the value, I now know that if I have a TV that is $15.99, that it would fall into this category. If I had a TV that was $1,600, it would fall into that category. Maybe if I had TVs that had cents to them too, like change as well, I might need to even go out further to help me differentiate. But if I decide to make that one 1599.5, I need to make sure I'm counting by a consistent number. So if I changed that to the midpoint, I would have to change this to the midpoint as well to be 1699.5. Notice I've just counted by 100. Then I would make this one into the midpoint. It would be the midpoint between 1799 and 1800. Which would be 1799 and a half. And I just keep counting by hundreds. So 1899 and a half and 1999 and a half. And it just makes it more obvious to my reader where that whole number of 1600, where it would fall. Now I'd also have to change this one, go back 100, so that I'm at 1499.5. So I've counted by a consistent amount all the way. So this just gives it a little more precision. We could have left it the way it was. Maybe that's prettier. And if you're trying to display it in some sort of publication where you want it to look pretty, then maybe you leave it at 1500, 1600, 1700. But then you kind of have to decide which side does that 1600 go on. This just gives it a little more precision so I know exactly where my data falls. And the way we did this was we found the midpoint. Let me just teach you a minute about where the midpoint is. We just kind of saw where it was in the middle. We said between 1599 and 1600 is at a halfway place. But if I wanted to show you that mathematically, what I could do is just take those two numbers and add them together and divide by 2, and that would give me the midpoint. So to find the midpoint of two numbers, you can just add them together and divide by 2. Watch, if I do that, I'm gonna still end up with that same 1599 and a half. So in this case, I end up with 9 and 9, 11 carrier 1 to 31.99. I'm gonna divide that by 2. Well, 2 goes into 3 one time with 1 left over. 2 goes into 11 5 times with 1 left over. 2 goes into 19 9 times with 1 left over. 2 goes into 19 9 times with 1 left over, but I need a decimal here. 2 goes into 10 5 times. Notice I ended up with that 1599.5. So to find the midpoint, you can just add two numbers together and divide by 2. So here's my histogram. The only thing that it's lacking is a title. All of my displays should have a title to let the reader know at a glance exactly what data they're looking at. So here's my 3D TV prices. And there's our histogram. Now we've lost our data within here, just as we lost our data when we created the frequency table, but we can begin to look and see where most of our TV prices lie. Let's create a histogram for the professor's commute. In this case, I'm going to do the same thing. I'm going to make a vertical axis and a horizontal axis. Give myself a little room down here. I only need to be able to count to 4, so I start at 0 and I'm counting up. I will count by ones since I'm only going to 4. If I were counting to a larger number, I might count by a different thing. I don't want to count by too big though. I want to keep it as small as I possibly can. But the big deal is I must always start at 0. On the vertical axis there, I have my frequencies. In this case, my frequencies are the number of professors. Then my categories or my classes or bins are the number of miles. So I'm going to start at that smallest one. This one happens to be 0. On my vertical axis, I always need to start at 0. On my horizontal axis, I can start it at whatever my minimum number is. So here I'm going to count by those 2's. So 0, 2, 4, 6, 8, 10, 12 to make sure I get them all in. If I wanted to make it more precise, I would do that same thing where I look at the midpoint between 1.9 and 2. Well, halfway between 1.9 and 2 would be 1.95. So I could change this to 1.95 to make it more precise, make it better for my reader to know right where the 2 is falling. Or this way works as well. I'm going to now make my bars for each category. So this was 2 high. The next one goes up to 3. The next one is 3 again. Then 4. Then 3. Then 3. Now along here I need my label of miles. And then I need my title of the professor's commute or the number of miles a professor drives. And there I have my histogram that shows the frequency of each one. It's pretty much uniform, or it's pretty well spread out, but each category has about the same number of professors in it. And remember again what this bar means. This bar means I have 2 values between 0 and 2. They might both be 1. They might be 0.1. They might be 1.1. I don't know what they are. I just know there are 2 values between 0 and 2. In this bar, I have 4 values between 6 and 8. Again, I don't know exactly what those data points were, but I know it's something between 6 and 8, like maybe 6.1, 6.6, 7, and 7.2. I don't know, just something in that range. And there are 4 values there. So these both are histograms, and those histograms are just frequency distributions. Math Made Simple, it's Simpson Math. Thanks for watching.